start. So we define design as the maximum output in any system, but that is never achievable. We have something called design capacity, which is basically the maximum output under ideal conditions. And we move from there to get to what's is often used, which is the effective capacity, which takes into account work breaks, product mix, which is basically the changes of different products, because factories and plants don't make just one product, scheduling difficulties, equipment maintenance, failure, delays, employee breaks. So it takes account into that, all these things, and we get a number, which is the effective capacity. And that's a very important number. That's what we're going to be used in a lot of the problems we will see in this class. So let's dive into break-even analysis. So here in this case, in break-even analysis for process design, we're looking at fixed and variable cost. So we'll have more than one, so we'll have a scenario, sometimes more than one scenario, and then there's a fixed and variable cost, and we want to decide at what point do we break even in terms we cover the expenses of our investment. So these are basically the equations involved here. So again, we have fixed cost, variable cost per unit, total cost, total revenue, which is TR, revenue per unit, quantity, break-even point. That's going to be very important, and this is where this equation is coming from. The quantity break-even quantity, which is the quantity where you start making profit. This is the quantity that you start. So at that point, you break even that one additional unit or one additional production unit will actually start producing profit after that point. So we could calculate, so we have here multiple equations. We have an equation to calculate the total cost. We have an equation to calculate the total variable cost. But what's going to be very important is this equation, the break-even quantity equation. And we're going to use it often when we have question asking for the break-even quantity. We have another equation that looks at any quantity. So Q at a given fixed cost and P, which is profit. So at this much profit, how much quantity you would need to produce. So it gives you a corresponding quantity for the profit point. And also this is a profit equation. We have two different profit equations. And so we have all these equations. The best way to learn these equations is to do examples, and this is what we're going to do. So we're going to do examples to learn how to use these equations. So I'll give you a few seconds to read this question. If you need more time, just pause the video. So if you need more time, just pause the video. So we have a manufacturer here is debating whether to start producing hand sanitizer bottles or not for 1 year. If they decide, then they need to purchase 3 machines. So already we need 3 machines. So already seeing that there is going to be some form of fixed cost. So the machine will come at $7,300. So that's the fixed cost. While variable cost of making sanitizer bottle will account for $1.8 per bottle. So that's a variable cost. The revenue from each bottle is $6.3. So that's the price of it. That's how much revenue you're gonna get. So if they go ahead and decide to produce, so they're now debating, but if they decide to produce, how many bottles must be sold to break even? And then the next question asks you, if demand is around 1,100 bottle, is this a good investment? Yes or not? So now the first question asks us how many bottles must be sold to break even. So if we look at our set of equations, this is exactly the equation we should be using. The quantity for break even point. Now we need a fixed cost, R and V. So R is revenue and V is the variable cost. And we have all the information. We have the fixed cost right here. And we have the variable costs and we have the revenue. So we could just plug in the numbers. So Q is equal to fixed cost is 7,300. The revenue is 6.3 minus 1.8, which should give us 162.22. So we need to produce 1622 bottles to break even. Now, if they decide to produce 1,100 bottles, 1,100 bottles, is this a good investment? Well, 1,100 is less than 1,622, so they're not breaking even, so they're not covering their expenses, which means this would be a bad investment. So bad investment if they're only able to produce 1,100 bottles. So let's look at another question. So I'll give you a few seconds to read the question. So in this question, same type of question. We're also looking at hand sanitizer, 1 year. They want to be in for 1 year only. If they decide they need to purchase 3 machines, now the cost is different for the machines, 5,000. The variable cost for the hand sanitizer also has changed, 1.7. And the revenue from the bottles is 3.8. Now, if they decide to produce but only manage to produce 3,000 bottles, what is their gain or loss? Their gain and loss has to do with profit. So if you go back to the equations, we need to use these equations. So the equations that have to do with profit, we know the fixed cost, we know the variable cost, we know the revenue, and we know the quantity, so we could go ahead and calculate the profit. So this is the equation right here. So Q is equal to revenue minus variable cost. So this is the profit. It's going to be the Q, which is, they're saying 3,000, times the revenue we're getting, which is 3.8, minus the variable cost, which happens to be 1.7, and minus, and we're subtracting from that the fixed cost, which is 5,000 in this case. And that should give us $1,300. It's a positive number, so it's a gain. If it was a negative number, it would be a loss. Since it's a positive number, then they would gain $1,300 after they cover their expenses and everything, so it is a profit. So let's look at another question. So again, I'll give you Give you a few seconds to read the question. You could always pause the video. So in this question, there again, the same example of hand sanitizers, and the machines will come at a cost 5,500. The numbers are a little bit different. The variable cost is 1.2 per bottle, while the revenue is 7.2. Now, if they decide to produce and they would like a profit of $3,000, so their goal is profit of 3,000, what quantity should they be producing? So in this case, we have a profit, and we want to, based on that profit, get the quantity. And this is the equation we should be looking at. So let's go back to the question, and so this is Q. So Q is equal to the profit they told us. So they want a profit of 3,000. Plus the fixed cost, which is 5,500. And that's 7.2 is the revenue minus the variable cost 1.2, and that should give us 1416.67. So they should be producing 1,417 bottles to achieve that profit.